Welcome to Data Guy, the channel dedicated to helping you unlock the power of data.
Hey everyone, welcome to Data Guy. In this video, we're going to learn about understanding database design. We'll be covering topics like how data is organized, how data is connected and optimized, and everything from database schema and relationships to normalization. Okay, so let's get started. First, we'll understand what is database schema and ER diagrams. Okay, a database schema is like a blueprint. Okay, it shows how data is structured in tables. As you can see in the example, we have like 4 tables like customer, product, orders and employees. Okay, and everything is connected. So this is a basic database schema. Okay, and each table represents an entity. For example, we have a separate table for customers. We have a details. We have a separate table which has order details called for orders, and we have a separate table for products, and likewise for employees. Okay, and in these tables, each column or we say attributes describes a property of that entity. For example, a customer table will have columns like customer ID, first name, what is their anniversary date, what is their last name. So these things will be there. It basically explains the describes the attributes of the table. And each column has a data type defining what kind of data it stores. For example, customer ID, it is stored in the form of integer. First name and last name, it's stored in string format, and the date of birth is stored in the form of date. Okay, so the next one, that is data types in SQL. Some of the common data types used in SQL is string types, which is like char, varchar, text, and these data types is basically used for names, emails, etc. Second, we have the numeric types such as int, float, and decimal, and this data types is used for prices, quantities, or IDs column. Third, we have the date time types such as date, time, timestamp, which is basically used for order date or login times to represent these data. The fourth one is Boolean, which is basically true or false. Okay, and this is just a visual representation of SQL database. SQL data types. We'll be mostly working on numeric, string, and date time. A little bit of Boolean. We won't be using much of binary and special. This is just for your knowledge. Okay. Now we'll go to the next slide. Next is keys in database. Okay. So what are keys? Keys are what connect and identify data uniquely in a database. And we have some 4 types of keys. We'll go one by one. The first is a primary key. It basically uniquely identifies each records in a table. Example, the customer ID in the customers table is the primary key. The second one is foreign key. It basically links 2 tables together. Example, the same customer ID in the orders table, which is a foreign key. Okay, and I'll explain this with an example for better understanding. Okay, and the third one is unique key. It ensures all values in a columns are different. Example, email, candidate key. Okay, and columns that can potentially be a primary key. Okay, now let's go deep into one by one. First is primary key. Like I said, primary key is a column that uniquely identifies each row in the table, and every table in a database should have a primary key because it ensures uniqueness and integrity of the data. Okay, and the primary key's value must be assigned when inserting a record and never be updated. Usually when we create a table in a database, we actually mention that this particular column is a primary key. So that's what it means. And note, the relationship is allowed to have only one primary key. Like I said, for example, in the customer table, you have customer ID as well as email, but you can't put both of them as a primary key. You can only choose one. So we basically use customer ID as a primary key. Okay. Next is a foreign key. A foreign key is a column or a set of columns in a table that refers to the primary key of another table. It is used to establish relationship between two tables. Okay, the value in the foreign key columns, it must match with the values in the primary key columns of the referred table. Okay, on the right, when you see, if you see this example, you have two tables, one for department, the other one for employees. In the department table, the department ID is the primary key, but the same department ID in the employee table is the foreign key. Okay, in the department table, you won't see any department ID which is repeating, because each row is unique, because the primary key is department ID, hence there's no duplicate values. But when you see the employee table, you can see that 101 is repeated, 103 is repeated. So this is basically foreign key. And using this department ID, the department table and the employee tables are joined, or basically related. Okay, if you want to find the department details of this employee Sana, she's from the she's department ID is 101. 101 department name is IT, and the department location is FC89, and her department budget is 5 lakhs. So that is how the data will be retrieved. Okay. Now the next one is unique key. Okay. A unique key is unique for all records of the table. Non-updatable, meaning its value cannot be changed once assigned. Okay, and but may have null value. Okay, let me explain this. Like I said, email is unique, customer ID is also unique, but we don't take email as a primary key. We take customer ID as a primary key, whereas email is a unique key. Okay, because one of the main difference between the primary key and the unique key is that unique key can have null values. Okay, but primary key can't have null values. A value should be there. If it is empty, it will not allow you to create that particular record. Okay, it basically means that a customer should have a customer ID, but may or may not have an email ID. That is what it means. Okay, fourth one is the candidate key. Like I said, any column or set of column that can act as a primary key is referred to as candidate key. And this is, we don't actually use this candidate key a lot. This is just for theoretical purpose, where you can just know about it, but we're not going to use much of it. Next, we'll talk about relationships in databases. Okay, there are three main types of relationships. The first one is one-to-one relationship. If you look at this example, we have a customer table and a capital table. Every country will have only one capital. Okay, it is not that one country will have 2 or 3 capitals. So it is not like that. So every country will have one capital. It means that one country is related to one capital name. Okay, so that is called one-to-one relationship. And the second one is one-to-many. And most of the time in our databases, we will be using this one-to-many relationships. It basically means that if you look at this example, one customer can place many orders, okay, with the same or different items. Okay, that's what it basically means. In this order table will have order ID which is unique, but in the items table, this order ID, we will have multiple same order ID multiple times, because this is an item table. Like for example, one order has 4 items, hence in the item table we will have 4 rows with the same order ID. It means that one-to-many relationship. This is what it means. Okay, we'll go to the next one. And the third type of relationships is many-to-many. Okay, and this is one of the best example to understand this. We have author and books. One author can write multiple books. At the same time, one book can have multiple orders. You see where a book is written by 2 or 3 people, means that the book can have multiple authors. Okay, so this is the best example for many-to-many relationships. Okay, Now the next topic is we're going to do is normalization and denormalization. So first we'll understand what normalization means. It basically means breaking larger table into smaller related ones to reduce redundancy. Okay, normalization ensures your data is consistent, efficient, and easy to maintain. What basically normalization means: breaking larger tables into smaller tables. If you look at the visual here, we have 4 columns in the larger database table, which is further split into 2 tables with 2 columns each. This is basic. This is a basic concept of normalization. Okay, and then we also have the denormalization, and this visual is an example of denormalization. Okay, where we have 2 different tables, but it is merged into one. It's called denormalization. Okay, so sometimes we do denormalizations, and most of the time we do normalizations, and basically it depends on your use case. You can do normalization for consistency and denormalization for speed. Okay, so depending on your use case. Okay, and we use denormalization, that is combining tables for faster reads, especially in data warehousing or in data analytics. We'll be using denormalization. So that's about it. Just to wrap it up, in this series we have learned how data is structured, connected, and optimized for performance. And in the next module we'll be start writing SQL queries and thus bringing design to life. Okay, what all we have learned till now theoretically, we'll be doing it in a practical way in a MySQL workbench, where we will be writing SQL queries. We'll be working with joins, subqueries, Windows function. There's a lot more exciting thing to come. So I'll see you in the next one.
If you enjoyed this video, please make sure to hit that like button. It really helps the channel grow. And if you haven't already, subscribe to the Data Guy channel.